So now that I've talked about extrema for a little bit, what's a minimum and what's a maximum, how do we find these things? Do we just look at a graph and point at it, or what goes on? So this is what we're going to do. So here's the key to finding these points. Finding these points. I'll just say extrema. Okay? So let's look at what could happen. So let's say we have some maximum. Okay? So here's the maximum. All right? Let's say we have a minimum of some sort. So there's a minimum. And we could also have something that looks, it doesn't even have to be like differentiable at that point, right? So this is still a maximum. It's very on the tip there. Okay, so what's the commonality between all of these? So we're actually going to have to look a little bit deeper and say that, let's look at the tangent lines, okay? So let's look at tangent lines to the graph at these points. So tangent lines, I'll say lines. Okay, so let's draw one on the first one. So there's one, okay? Here's the one at this point. And then this one, it just doesn't exist, right? Because it's not differentiable. So this one, the tangent line does not exist because there isn't a unique one. Okay. Well, this one here. Oh, okay. I'll just label them minimum, maximum, or maximum, minimum, and then another max. Okay, just so we know. And anyway, so for these two though, the tangent line is actually horizontal, right? So tangent lines are either horizontal, or they do not exist, right? So what does that mean? So now that we've found this, we can kind of extend that to what we know about like our calculus knowledge so far. Okay, so when the tangent line, being horizontal, when that's horizontal or doesn't exist, let's see what that means. Horizontal or does not exist. Okay, so the tangent line is related to, well, the tangent line, the slope of the tangent line anyways. So slope of tangent line is given by f prime of x, right? The first derivative of our original function. This gives us the slope of the tangent line. So if we have that being horizontal or does not exist, then that means that f prime of x must equal 0, right? If we want our slope to be 0, if our line is to be horizontal, so that's either 0 or it does not exist as well. Okay, so if it does not exist, that means it's vertical, like up and down, or it just doesn't. There is no one answer. Okay, so this is an important point here. This defines what is a critical point for us. So here's a new term. We're going to call it critical points. Okay, so critical points, what are those? They're basically, so critical points are points where for x equals c, then we have that f prime of c is equal to 0, or f prime of c does not exist. Okay, so this box thing, that basically defines what value for x, that gives you these things, one of these things, where f prime of x is equal to 0 or does not exist. At those x values are called a certain name, called critical points. Okay, so this is an important term here to remember. All right, so these are critical, I guess, because by this one guy. So critical points, well, I'll just say they're important. So they're important because by, so these are important, okay, because by Fermat's theorem, I don't really know if I'm saying that right, but because by Fermat's theorem, we have that if f of c, so if this function is a local minimum or a maximum, so if it's a local extrema of any sort, then we see by this theorem that c is a critical point of f. It must be a critical point of f of x. And again, critical point meaning that f prime of c is equal to 0 or it does not exist, okay? So that's always a good, I don't know why I put a parenthesis there. But anyways, that's always a good starting point for finding those local extrema, okay? So now let's go more into detail about optimizing. So this whole process is called optimizing, remember? So that is the process of finding maximums and minimums. Okay, so what we're going to do is optimize, or we're going to do optimizing on a closed interval. Closed interval. Okay, so if we're doing that, then we're basically just going to start with assuming that f is continuous. So we're going to say assuming f of x is continuous on closed interval AB. Then if our f of c, if f of some value c is a maximum or minimum, is a max or minimum on that closed interval, so on, again, AB with square brackets, right? Then we can say that c is either a critical point, so meaning that the first derivative at that point is 0 is equal to 0 or it does not exist, or c is one of the endpoints. One of the endpoints. Endpoints, A or B. Okay? A or B. Okay? Alright, so how are we going to find, so this is an important part. Basically, it's just saying that when you have a maximum or a minimum on an interval, let's say you have something like this, right? So let's say our interval is A to B. Okay, so here's A, here's B. So we could either have where this is the following. So we have our minimum. We can see a minimum here, so that's C, right? So here's our minimum. That's good. That's at a critical point where a tangent line is horizontal. Okay, and then our we just found the minimum. So our maximum is actually at an endpoint. It's at B, right? So here we can't like analyze the tangent line or anything because our interval ended, but we do know it's an endpoint. So B would be the local maximum, and this is the local minimum. And this is also a local maximum, but that would be, this is a local max, but not the absolute maximum. It's not the very highest point on our interval, okay? So anyways, let's figure out the steps to find, the real steps, the definite, concrete steps to find your minimum or maximum, to find minimum or maximum. Okay, so this is what we're going to do. What we're going to do is, first of all, find those critical points. So find critical points by seeking out where our f prime of x, where f prime of x is equal to 0 or does not exist. And this is like and or, because if it does equal 0 at a certain point and it does not exist at another point, then you could list both of those as critical points, right? So now, after we do that, we're going to plug in critical points, critical x values, right? So critical points, and this is the important part, and the endpoints and endpoints. Don't forget about those guys, because we could have maxes or mins at the x point, at the endpoints. We're going to plug those into endpoints into our original function, so f of x. And then the last thing is just to compare all of the values that we obtain to find, or identify, I'll say, identify the maximum and the minimum. Okay, so you just identify the lowest, the thing that gives you, or the point that gives you the lowest value. When you plug it in, you identify that as the minimum, and then conversely, whatever gives you the highest value, that's your maximum. Okay, so let's do an example of this following these steps.